evaluate this double integral x square. The integrand is x square, where E is the region bounded by the ellipse, and we are asked to use these change of variables. X equals 2u and y equals 3v, and here is the ellipse. We don't have to graph this ellipse, in fact, okay, because we will change this graph, this region, into different one. And the idea is, when we use these change of variables, the shape will be easier to use, and this integrand, which is x square, that will be easier to integrate. So let's use these change of variables for this ellipse. 9x squared plus 4y squared equals 36. Use x and y from there, then we get this. Simplify, so the new region is bounded by this, okay, u squared plus v squared equals 1. In fact, this is like x squared plus y squared equals 1. So initially this was on ax, y. Now our new plane will be uv, and the equation is u squared plus v squared equals 1. That is like x squared plus y squared equals 1. Standard circle, that means centered at 0, 0 with radius 1. Okay, so the new region will be, in our case, where we are integrating on uv plane. By the way, it will be a unit circle. Okay, so this is the new region, and yes, in fact, this is easier than this. Okay, now we want to convert this integral into new region. Okay, for we need the Jacobian. So here is the Jacobian with this in uv. That's partial derivative of x with respect to u v, and partial of y in uv. That is partial of x with respect to u. X is just 2u. There is no v. There is no v, means 2, 0. How about y? Y is 3v. There is no u, so 0, 3. So 6 minus 0 is 6. And this new region, let's say D. This was E. Okay, now we have D. And we change this x square. Here is the integrand. So originally we had x squared dA. Now with the change of variables, we are in new region, let's say D, and x squared is 4u squared, and we'll have Jacobian, absolute value of Jacobian, which is 6. Absolute value of 6 is 6, and new area, I mean, in terms of area, change in area, but this is given from D. Okay, let's simplify this. 6 times 4, 24, we can pull outside, so we have D, this circle, dA, u squared dA. And as we've done earlier, whenever we have a circle, u squared plus v squared equals 1, that's the case. If we go into polar coordinates, then this will be much easier to use, because in polar, this is simply r squared equals 1, or r equals 1. Just, okay, that's the equation. So if we want to go in that way, okay. So when we change this into polar, another transformation, so this one is equal to, when we go to polar form, this 24 outside, so we'll have double integral still there. U is like x is r cosine theta, so this is still r cosine theta squared, so r squared cosine squared theta, and this dA becomes r dr d theta, r dr d theta, so r first and theta outside. So circle means we are going 360, so 0 through 2 pi, and r starting at 0 all the way outside is 1, so 0 to 1. Okay, so we're going to integrate this. So let me write here. So 24. So let's integrate inside with respect to r. So we have r square, and here is one more r cube. In entire derivative of r cube is, this is theta 0 2 pi. Cosine square theta is kind of constant. This is constant with respect to r, so we can take outside that cosine square theta. R square r cube. R cube entire derivative is r4 over 4. And we are going from 0 to 1. D theta. Okay. This is 24. In fact, this 4 can be pulled all the way outside. 6. And 0. So theta equals 0 to 2 pi. Okay. And when we plug in upper limit, 1 to the 4 is out. So 1 raised to 4 is 1 minus 0, just 1. I mean, there is nothing here. This 4 is outside. Now we are left with cosine square d theta. And for cosine square, this is 6. We cannot integrate because it's a square cube, so we need to go for a double angle. That's the only way here. 0 through 2 pi. And cosine square is 1 plus cosine 2 theta all over 2. Sine square theta would have been 1 minus cosine 2 theta over 2 d theta. This 2 can be pulled all the way outside, in fact 3. Let's integrate. Antiderivative of 1 is x, but our variable is theta, plus cosine is sine over 2 because there's angle 2, and we evaluate from 0 to 2 pi. So the final answer we are getting here now 3. Let's plug in upper limit. This is 2 pi plus sine 2 times 2 pi, sine 4 pi, which is 0 over 2 0. That's the upper limit part, minus lower limit 0 plus sine 0 is 0. So basically no contribution. So just 2 pi times 3, 6 pi. Final.